All right, welcome to 2.6 part 2. In the previous lesson, we just talked about how to take a graph. Mostly we did the x squared graph, the parabola shape, and just talked about how to shift it up, down, left, right. So we started with this parent function that looked like this, and then shifted it all over the place. Next is a different kinds of transformation, as we're going to stretch it out or compress it. So just to help you understand that, here's a picture. We got a puppy dog this time, but here's a normal one. And if we were to stretch it, we always talk about it in the vertical sense. So this one gets stretched, pulled vertically. It would look like that, and then a compression would be this way, squishing it this way. That's called a compression. All right, that's the first part of this video, and the second part will be about reflections and how do we make a graph reflection or flip over the x or the y axis. So two parts to today's lesson. Okay, so just to give you an idea what a stretch or compress looks like, we've got this blue function here, right? This wavy function, and the red example is an example of stretching it, right? And we're always thinking in the vertical sense. So I just got pulled up or down, I guess. But stretched out more than it was before. Okay, versus the green one represents a compress because it got smushed. Okay, so we want to do our parent function again of x squared, and how do we want to stretch and compress it? Okay, in your notes, this is, I think, a good thing to have down is how you do a stretch or compress is you multiply the function by some value a. Okay, and depending on what a is, that'll either make it stretch or compress. All right, so keep in mind from yesterday, when we want it to shift, we would like add or subtract, right? So if you want to make it go up 4 or something, we would write the function that way. Okay, so adding, subtracting moves it up, down, left, right, depending on where you put the number and whether it's positive or negative. And then to stretch or compress, you multiply. And so that's what we're going to investigate here is what number you need to multiply by to make it stretch or compress. Okay, so before we fill this in, I think it's good to kind of investigate it. And so if you have a graphing calculator, you can use that. Or if you don't, you can use this DESMOS site called Desmos. And it's kind of a cool way to just learn a little bit about how this works. So I'm going to pull up the calculator here. And what I have is just the basic x squared graphed in red here. And then we're going to multiply it by a bunch of different numbers and see what happens. Right? So you can do this on your own. Just type in whatever you want, number in front, and then kind of see what happens to the graph. All right, so once you've done that, you can watch the rest of this part and see what we've learned. Okay, so hopefully what you see with this 3 in front is it essentially stretches it vertically. Again, in that you could seem like it'd be compressed if we thought about it horizontally, but vertically it would have been stretched. All right, and so the reason for that is it just takes all the x squared values and multiplies them by 3. Right, so the best thing I can give you here is if you look at a point, like a specific point on the red one here, 1, 1 is a point. That makes sense. When you put in 1, square it, you get 1 in the red function, right? But in the blue one, we after we square it to get 1, we multiply it by 3. So now when we have x of 1, we get an output of 3, right? So that multiplying by 3 just makes it go up faster than it did before, right? It's called a stretch, right? So if you want to take a guess, what do you think 7 would do, right? And if we turn this on, it just stretches it even more, right? Because after you square it, you multiply by 7, so now it's going up even faster than before. Okay, so what happens if you have a little number like a fraction, like 1/2 or 1/5 or something, is it's kind of the same thing, except now it doesn't go up as fast, right? Because after we square x here, we get 1, and then take it times a half, and so we're at 1/2 instead of 1. So if I look at the purple one, I can highlight it here with my mouse. This might be kind of hard. But if I do x of 1, I get a half, right? So this multiply by half makes it go up less fast. And similarly, 1/5 makes it go even less faster than that. So back in our notes over here, we want to make it just a quick note that to make it stretch, all right, and see if you could generalize this. What value for a will make it stretch? All right, we can have some examples. But generally, like if a is greater than 1, it's going to stretch. Okay, so an example might be 2x squared or something that would make our parent shift. All right, and a compress is an a value that's between 0 and 1. Okay, so any fraction decimals or something, so we could do 1/2 or maybe 0.7. Any of those will make it compress. Just to finish off this stretch compress deal, just a couple questions. One is, so this is a sine x. So now we're going to imagine that our parent function is just sine x, which you can graph on Desmos if you want. It's kind of cool, actually. It makes a wavy shape in Desmos, which I can't draw very well here, but it makes that shape. So how would this 4 transform and how would this 1, 6? So pause the video, think about it, and then come back. First one, hopefully you got that this is going to stretch because the a is greater than 1. And this 1/6 is going to make it compress again vertically because this sixth is between 0 and 1. Right? And again, just so you know what it would look like, you're compressing it vertically, so it would be flatter. It'd look something like that. Right? Obviously, I'm not drawing it very well, but it would just compress it down. Okay, last sample question for you. This combines a few things, right? So we're still doing our x squared parent, which is just that parabola shape. All right, but now there's multiple things happening to it. So pause the video again and say what's happening to our x squared in these two cases. If you get stuck, I'll graph on Desmos. Okay, so back with you. The first one, this 3 multiplies. Multiply again makes it stretch or compress. So because we're more than 1 here, that's going to make it stretch. Sometimes they'll say stretch by factor 3. You might see that in homework sometimes, so I'll write that here. Okay, and this -8 is not in the parentheses with x, right? So that's going to make it go up or down, and this one, because it's subtraction, goes down 8. All right, second one, it has a multiply again, so that's a stretch or compress, and because it is between 1 and 0, that's going to be compressed by factor 1/2, and then this 2 is going to make it go opposite of what we think. So I think that would go right. So it's actually going to go left 2. So this parabola would have gone left 2 and then compressed. Okay, that's it for part 1 of this day 2. And so there'll be a second video talking about reflections next.